Welcome to our first fix guide. I'm Matt, the trainer for Stevelatron UK. In this guide we will look at what supplies are required for the air source heat pump range. I will also show you the maximum demand, which will assist with maximum demand and diversity calculations, and also explain the bivalent operation and the current drawn in both mono and bivalent operation. Firstly, we will look at the first fix overview. This will look at the supplies required, the number of isolators, and any accessories that you may need to install with the Stevelatron equipment. We shall discuss RCD and MCB types and what is required for the air source heat pump range. We will then look at the following products: the HPA 08 CS Plus INT, the WPL A07 Premium, and the WPL25 ACS. Let's look and see what is required for the first fix for the air source heat pump range. For all of the air source range, we may require up to 4 individual supplies. Each supply will need a rotary isolator installed close to the outdoor unit. Looking at the supplies on the back of the air source heat pump, we will find X3, which is our compressor supply, X4, which is our controls. We also have 2 onboard elements, a 3 and 3.2 kilowatt element. If you are connecting the 3 kilowatt element, you will need a 16 amp supply. If you are connecting both the 3 and 3.2 kilowatt elements, you will need 2 16 amp supplies. We also need to install a communications cable. This is a Cat5 or Cat6 screen data cable that will run from the outdoor unit to the WPM4 controller located inside the property or in the plant room. Our air source heat pump range require an external outdoor weather compensation sensor. This is a hardwired connection and is not wireless. It is best practice during the first fix of the supplies to install a 2-core cable or communication cable from the north facing wall to the plant room where the WPM4 is located. If you are installing and using the Stevelatron FET room thermostats within the property, I would recommend to install a communication cable from the WPM4 controller to the area or location where the FET room thermostat will be installed. Another Stevelatron accessory that must be considered during the first fix procedure is the Internet Service Gateway. Now this will need a power supply and also a LAN connection. It will normally be located close or near the WPM4 controller. As we can see on our example, we have our LAN connection or LAN port installed next to a Type G 3-pin UK socket. This will allow us to power up the ISG and also connect it to our router. The Internet Service Gateway is not wireless, it's a hardwired connection only. You must check what the available load for the property is. For example, the property may only have a 60 or 80 amp supply. This will determine if the heat pump can be installed without upgrading the supply. The fuse size doesn't determine the maximum current drawn by the product. It is to provide suitable protection. For example, the control circuit requires a 16 amp supply. However, the normal operating load is around 1 amp. The WPM4 controller has the capacity for a wide range of pumps and mixers to be powered from the wiring center. The onboard elements do not normally operate alongside the compressor. This would be a bivalent operation, effectively using 2 heat sources. The normal operation will either be the compressor or the onboard elements. We have 2 options for the onboard elements. either a 3 kilowatt element or a 3.2 kilowatt element. Or you can bring in two 16 amp supplies to the onboard elements, providing 6.2 kilowatts electrical backup. The ENA application has become more streamlined, featuring a new app. This allows you to check if the heat pump can be connected to the existing supply. All of the Steve Electron heat pumps are on the ENA database, with the option for either one or both onboard immersions being connected. As I discussed in the previous slide, the onboard elements will never operate at the same time as the compressor circuit. I have created an example to show the current drawn in either operating mode. I have used the WPL25 ACS, and for our example, we are saying the maximum current drawn for the compressor is 25 amp. The normal operating current for our control system is 1 amp, which gives us a total of 26 amp for the current drawn for the compressor circuit alone. We have connected both elements, so we now have 6.2 kilowatts of electrical elements connected, and our controls. The elements are drawing 13 amp each, and our control circuit is drawing 1 amp, giving us a total of 27 amps. As I discussed in this section, we will look at the RCD and MCB types required for the air source heat pump range. The Stiebel Eltron air source heat pumps can have onboard elements built in. The onboard elements and the control circuits can be protected with RCBOs. However, the compressor will need a Type B MCB. You will need to ensure that there is suitable protection and you have the correct RCD installed. You will need a Type B RCD. Type A and AC are unsuitable. You will need to ensure that the electrical design, installation, testing and certification of the circuit to our equipment are in accordance with BS 7671 electrical wiring regulations. In this section, we will see what is required for the HPA08 CS Plus INT air source heat pump. The figures shown on the screen are for the HPA08 CS Plus INT. These values are the maximum demand at the air temperature of -7 degrees. The compressor will need circuit protection of 25 amps. However, the maximum current drawn is 20.9 amps. Our control circuit needs to be protected to 16 amps, and the normal operating current is 1 amp. So this means the current drawn by the heat pump in mono operation using only the compressor is 21.9 amps. If you have connected both 3 and 3.2 kilowatt immersions, then the current drawn will be 27 amps. This is displaying either the compressor or the boosters or elements running independently, so it's a mono operation. The onboard elements require 16 amp protection, but the normal operating current is around 13 amps. We also need to ensure the control circuit is still active and on, so this will be a 16 amp protection or fuse required, but the normal operating current is 1 amp. In this example, we will look at the HPA08 CS Plus INT working in bivalent operation. Now, bivalent operation is when you have 2 or more heat sources active at the same time. Our example will include our compressor and also our 3 and 3.2 kilowatt immersions. The first example is using the 3 kilowatt immersion and the compressor. The protection required for our compressor circuit is 25 amps. However, our maximum current drawn at -7 degrees is 20.9 amps. Our control circuit requires a 16 amp protection with a normal operating current of 1 amp. The 3 kilowatt immersion requires 16 amp protection. However, the normal operating current is 13 amp. This brings the total to 34.9 amps. If we connect the second onboard immersion, so we have our 3 and 3.2 kilowatt immersion and our compressor circuit, we can see an increase in the total demand for the system. So our compressor requires 25 amp protection with a maximum current drawn of 20.9 amps. Our controls require a 16 amp protection with a normal operating current of 1 amp. Both 3 and 3.2 kilowatt immersions require 16 amp protection. However, they have a normal operating current of around 13 amps each. This brings the total to 47.9 amps for the bivalent system using both onboard immersions. In this section, we will look at what is required for the WPL A07 Premium as mono operation and also a bivalent operation. We can now have a look and see what is required for the WPL A07 Premium and what our maximum demand is. This will be operating in mono operation. The compressor requires 25 amp protection as a maximum current drawn at -7 degrees of 24 amps. Our controls require 16 amp protection. However, the normal operating current is 1 amp. This brings the total to 25 amps. If we connect both onboard immersions, we will need 16 amp protection for both the 3 and 3.2 kilowatt immersions. However, the normal operating current is around 13 amps each. We also need our 16 amp supply and protection for our control circuit. However, the normal operating current is 1 amp. This brings the total demand to 27 amps. Now we've seen what is required for the WPL A07 Premium in mono operation, we can have a look at what is required and the maximum demand for bivalent operation. Our first example is the compressor and 3 kilowatt immersion operating at the same time. We require a 25 amp protection for the compressor circuit and the maximum current drawn at -7 degrees outside air temperature is 24 amps. Our controls require 16 amp protection and the normal operating current is 1 amp, and the 3 kilowatt immersion requires 16 amps protection with a normal operating current of 13 amps. This brings the total to 34.9 amps. When using both immersions, we see a higher maximum demand. We still require 25 amp protection for our compressor circuit with a maximum current drawn of 24 amps, 16 amp protection for both the 3 and 3.2 kilowatt immersion with a normal operating current of around 13 amps each, and 16 amp protection for our control circuit with a normal operating current of 1 amp. This brings the total to 51 amps. In this section, we will see what is required for the WPL25 ACS in mono and also bivalent operation. The WPL25 ACS in mono operation for the compressor requires 32 amp protection and the maximum current drawn by the compressor at -7 degrees is 30 amps. The controls require 16 amp protection and the normal operating current is 1 amp. This brings the total to 31 amps. The onboard immersions with both 3 and 3.2 kilowatt connected, we require 16 amp protection for both 3 and 3.2 kilowatt immersions with a normal operating current of 13 amps each. Our controls require 16 amp protection and has a normal operating current of 1 amp. This brings the total to 27 amps. Now we will look at the WPL25 ACS operating in bivalent operation. We have two examples. Our first example shows the compressor operating with the 3 kilowatt immersion, and our second example is our compressor operating with the 3 and 3.2 kilowatt immersion. So our first example, we require 32 amp protection for our compressor circuit with a maximum current drawn at -7 degrees outside air temperature of 30 amps. The controls require 16 amp protection with a normal operating current of 1 amp, and the 3 kilowatt immersion requires 16 amp protection with a normal operating current of 13 amps. This brings the maximum demand to 44 amps. In our second example, with the 3 and 3.2 kilowatt immersion operating alongside the compressor, we still need the 32 amp protection for our compressor circuit, and the compressor circuit is drawing a maximum current of 30 amps. The 3 kilowatt requires a 16 amp protection with a normal operating current of 13 amps. The 3.2 kilowatt immersion requires 16 amp protection with a normal operating current of 13 amps, and our controls require 16 amp protection with a normal operating current of 1 amp. This brings the total or maximum demand to 57 amps. We hope you find this video useful. For any further information, feel free to contact our technical team on 0151 346 2300 or by email, which is technical@stiebel-eltron.co.uk. Don't forget to like and subscribe for more videos about Stiebel-Eltron products.